In this second tutorial on outputs, I will be going over the setup of circuits in Arduino code for a vibration motor, servomotor, and stepper motor. In this tutorial, the first component we will be creating a circuit for is a small vibrating motor disc, also called a vibe motor. When powered, these small motors oscillate very quickly, vibrating on surfaces and creating small buzzing sounds. These motors are similar to ones you would find in your cell phones. In this example, we will be turning the motor on for 1 second and off for 1 second repeatedly. This circuit is quite easy to set up as the motor that we are working with only has 2 wires, one blue and one red. To set up this circuit, connect the red wire from the motor to the 5-volt pin on the Arduino board. And then connect the blue wire to digital pin 2. Once that is done, we can take a look at the sketch. The sketch for this component and the commands that we are using should be straightforward and simple to understand, considering we have already seen these lines of code in the LED blink light sketch. In the variable section, we are declaring vibe motor is numerically equal to digital pin 2. And in the void setup section, we are declaring vibe motor or digital pin 2 as an output. In the void loop section, we are stating that we want to send the vibe motor a high signal, 5 volts, or turn it on, and have that command wait or stay on for 1 second. After that, we want to send the vibe motor a low signal or 0 volts, turning it off, then wait another second before the code is looped, and this all happens again. With the code complete, we can go ahead and verify and then upload the sketch to our Arduino boards. Once the code is uploaded, you should see the vibrating motor turn on for 1 second and then off for 1 second over and over again. The second circuit we will be making is with a servo motor, also referred to as RC servos. These motors generally use low voltage, which makes them easily compatible with microcontrollers like the Arduino. In this tutorial, we will be setting up a servo circuit with our Arduinos and programming this motor to sweep back and forth from various predetermined positions. What separates servo motors from some of the other motors available is that the rotation of servos are based on a gear train inside the motor casing. Depending on the motor, gear size, and the material they're made out of, either metal or plastic, servos output a different amount of torque and precision positioning. In general, there are 3 categories of servos. The first is the 180-degree servo, which can only rotate 180 degrees. There is then a 360-degree continuous rotation servo that, like the name alludes to, can rotate 360 degrees continuously, and the last is the analog feedback servo, which sends back to the microcontroller the position of the servo arm for an accurate understanding of its location. For this tutorial, we will be using a 180-degree rotation servo. In terms of making the circuit, servos will usually have a red and black wire. Connect the red wire to 5 volts on the Arduino board, and connect the black wire to ground. The last wire, which is sometimes yellow or orange, will connect to digital pin 9. Once we have connected our servos, we can move on to the sketch. The first line of code in the sketch includes the servo library so that it can be referenced later on in the code. In the variable section, we are creating a servo object and calling it myServo. The second line of code is defining the variable to store the servo position. And in the void setup section, we are declaring that myServo is attached to digital pin 9. In the void loop section, we are first stating that we want the servo to go from a position 0 to 180 in 1 degree steps. The second line of code is executing that command and telling the servo to move. The delay states the time that the servo waits before it moves on to the next command. That next command is if the servo has reached 180, move it back to position 0. Again, the myServoWrite command tells the servo to move to its new position. Once we set the positions we want the servo to move back and forth from, and the code is finalized, we can go ahead and verify, and then upload our sketch to the Arduino board. As you will be able to see in the video, once the code is uploaded, the servo arm will move from 0 to 180 degrees back and forth repeatedly. The last circuit we will be making in this series of tutorials on outputs is with a stepper motor. Stepper motors are DC motors that move in discrete steps. Inside each step motor are copper coils that are organized in groups or phases. By turning these coils on and off, the motor rotates one step at a time. Stepper motors that are used with a microcontroller can achieve very precise positioning and can rotate fast. But, unlike the servo motors we just learned about, stepper motors don't have very much torque. Because of this, stepper motors are often used when you need precise rotational accuracy. In addition to these characteristics, stepper motors also have a low efficiency, meaning that they consume a lot of electricity even when they are not running or moving. Also, they generally have less torque at high speeds than at lower speeds. And, unlike the servo, there is no feedback to a microcontroller on its positioning. With all that said, the positioning on a stepper motor and its speed is much more superior than most of the other hobby-type motors that we use with our Arduinos. The stepper motor is a high-quality motor that is used in a variety of applications like small CNCs and even 3D printers. In regards to the rotation of stepper motors, they are able to turn 360 degrees continuously, but these motors have different degrees of rotation. What I mean when I say degrees of rotation is that the stepper motor, depending on how it is made, has a predetermined limit to what one step or 1 degree of rotation it can make. For example, the motor that we will be using today has a 1.8 degree of rotation. That means that if I program the motor to move one step, it will only move 1.8 degrees. If I want the motor to turn 360 degrees, I have to tell the motor to make 200 steps. I know that 200 steps is equal to 360 degrees, because if we take 360 and divide it by one step of the motor, which is 1.8 degrees, we get 200. So, if the motor turns 200 steps, it will be turning 360 degrees. If it turns 100 steps, it will be turning 180 degrees, and so on. The last distinction regarding stepper motors that we have to know is that there are two types, unipolar and bipolar stepper motors. These two categories deal with how the coils within the motor are charged. In a unipolar stepper motor, there are usually no less than 6 wires coming from the motor. That is because a unipolar stepper current flows in only half the coils at one time. Energizing these coils at different times is what creates the rotation of the motor. On the other hand, in a bipolar motor, which only usually has 4 wires, all the coils are energized, and depending on which way the current flows through the coils is what creates the motion. In this example today, we will be using a 12-volt bipolar 1.8 degree stepper motor and controlling the rotation of the stepper from the Arduino IDE serial monitor. While the circuit looks a little difficult and intimidating to set up, you will quickly realize that as we go through this, the wiring is the same for all 4 pins on the stepper motor, and that once you understand how to set up one, the other 3 wires can be set up quite quickly. Before I can explain the wiring, there is one last component that we have to look at, and that is the black chip in the center of the breadboard. This chip is called a dual H-bridge driver. An H-bridge is used to drive motors clockwise or anti-clockwise. To reverse the direction of a motor, the supply of current must be reversed as well, and this is what the H-bridge does. So, depending on what type of signal we tell our microcontroller to send to the motor, the H-bridge will either send the current in one direction to the motor's coils, or in the other, so that the motor will spin in the direction we want. With a bipolar motor, you cannot achieve clockwise or anti-clockwise rotation without the use of an H-bridge. So I'm quickly going to go over each leg of the H-bridge and explain what each pin connects to. The 4 exterior legs of the chip are the power inputs, and the 4 central pins are the 0-volt legs or ground. Then, the second pin from the top and bottom rows are the in pins. In pin 1, in pin 2, in pin 3, and in pin 4. We want to connect these pins to our Arduino board so that we can control the H-bridge and ultimately the current that will be outputted from it. The third leg from the top and the bottom of the chip are the output pins. We have output 1, output 2, output 3, and output 4. These are the pins which we will connect to our motor and that will send the current to the coils to make it run. Now, if we look back at our Fritzing circuit, we understand that we want to connect all 4 of the edge pins to the VIN pin. Because the motor requires 12 volts, we will be using the DC power jack to power the Arduino and will access that power through the VIN pin. After we have connected the power, we want to connect one of the ground pins on the H-bridge to the Arduino. Finally, we want to start connecting the digital pins and the motor wires to the H-bridge. So, for the first input, connect it to digital pin 11. And the first wire from the motor to the first output on the H-bridge. For the second input, connect it to digital pin 10.